Okay, so this video is focusing on solving exponential equations using logs. We can't solve them when we can change their bases to the same thing, but that only works in certain cases. So this is one that we can use all the time. The first thing we need to know in order to be able to use this method is what we call change of base. So our calculators are only really good at calculating base 10 really well, and we see that this first example does not have a base 10. It actually has a base of 5. So we're going to need to change it to base 10. So anytime we do change of base, we want to remember that log b of a can be rewritten as log of a divided by log of b. And it doesn't matter which number is like quantity-wise bigger. We're just looking for the base is always on the bottom and the argument number is always on the top. So here we have log of 32 divided by log of 5. So the nice thing is our calculator can do this for us. So I have my Desmos pulled up. I want to go to the function tab and then I can click log. And then inside the log, I'm going to put what's on top. So log 32, close the parentheses. Then I hit divide to make it into a fraction. You can also use the slash button on your keyboard. Then same thing, divided by log of 5. And I want to round to the to the thousands place. So I'm going to look at 3 numbers after the decimal and then look at the fourth to see if I'm going to round up or keep it the same. So here I would say 2.153 is log 32 divided by log 5. Okay. We have one more example just to show you we rewrite it the same way. So this would be log 46 divided by log 6. And to calculate, I'm just going to quickly replace the numbers in my log. So 46 over 6. And this gives me 2.137. Did not plan for those numbers to be as close as they are, but they are. All right, so next thing we need to know when we're using logs is we have to convert from log to exponential form, or from exponential form to log form. So we're going to follow this rule that b to the x equals n. We can rewrite that as log base b of n equals x. So we're going to just label our b, x, and n, and then we're going to move them around to be in the correct position for the log form. So 4 is in this position of our base, so it's our b. X minus 2 is in the position of our exponent, so that would be x. And then 30 is in the position of n. So I'm just going to rewrite. Log base b is 4 of n, which is 30, equals x minus 2. So I didn't change any of the numbers. I didn't have to calculate anything. All I did was label my terms and then change the order. So I'm going to do the same thing on the next one here. 5 is my b, x is the x, and 16 is the n. So I have log base 5, 16 equals x. And for the last example, before I can label what things are, I need to isolate the exponential portion. Or get this part by itself. So I'm going to add 4 to both sides. Okay. And then this is one that I could solve by rewriting both sides as powers of the same base. But just to continue illustrating here, and maybe you didn't recognize that, then we could do log base 32 of 16 equals x plus 6. So now we've converted to log form from exponential form. And now we are going to use those two things, the change of base and log form, to solve using exponentials. So solving when we can't actually change the base of something. So first thing we need to do is isolate the exponential. So in each of these, I'm going to circle the exponential part so you kind of know what we're looking for. In this case, our exponential is already isolated, so I can rewrite using the idea of logs. So log base 20 of 56 equals r. And then I can evaluate log base 20 of 56. So log of 56 divided by log of 20 equals r. I'm going to go over to my calculator and switch out my numbers. So 56 and 20. And I get r equals 1.344. I know it says 1.343, but I look at the 3, look next to it, 6 is greater than 5, so I round up to 4. Right? And same thing here with this next one. Start by subtracting 3 from both sides. Now I can see that I have it in exponential form. So I'm going to switch it to log form. So 9 is my base, 78 is the n, and n plus 10 is our exponent. So I'm going to go ahead and calculate the left side. So I'm going to plug in log 78 divided by log 9. And careful to write that that's equal to n plus 10. It's not just equal to n, but n plus 10. And then over on the side, I can switch. So we get 78 and 9. I'm going to bring it up to a new row, but I get 1.983. We still want to round to the thousands place, even when we're working inside of a number. So for this one, we have our number, but we're not quite done yet because we need to find what n itself is. So I'm going to subtract 10 from both sides. And I need to type this into my calculator. So 1.983 minus 10 is negative 8.017. Okay. All right, in this next one, we also need to isolate the exponential. So this piece right here. 11 to the n minus 8. So I'm going to start by adding 5 on both sides. And then now I can go ahead and write it in log form. Log base 11 of 54 equals n minus 8. Okay. This is log of 54 divided by log 11 equals n minus 8. Go back over here. Switch up my equation. So log 54 divided by log 8 gives us 1.664. Equals n minus 8. And then now we need to solve for n. So I'm going to add 8 to both sides. Cancel it out. And I get 9.664 equals n. Okay. All right. So our next one in order to isolate our exponential, we see that we have multiplication happening, right? So in order to undo multiplication, we need to divide both sides by 5. Okay, now we can write it in log form. So log base 6 of 4 equals 3n. Sorry if you can hear some background noise. My dog really wants my attention and is very upset that I am doing this video. So now we can calculate that. We're going to do log 4 divided by log 6 equals 3m. And go ahead and calculate that. Okay, and we get 0.774 equals 3m. And then to get rid of the 3 that's in front of the m, again, we are going to divide both sides by 3. So 0.74, oops, went back too far. 0.774 divided by 3 is equal to 0.258. Perfect. Okay. And then our last example. All right. So for this one, again, we're going to add 5 to both sides to isolate the exponential. Then we're going to rewrite in log form. We can never take the log of a negative number. So if a problem asks you to start taking the log of a negative number, that's actually going to be a no solution problem. So log 58 divided by log 8, 1 point, oops, I didn't even write that out, and I just did it on my calculator. But so that you can see what I did. And then that gave us 1.953 equals negative 5a. And then to eliminate the negative 5, we have to divide by negative 5 on both sides. If we just divide by a positive 5, that's not going to get rid of the negative like we want to. Oops. So divided by negative 5, we get negative 0.3906 equals a. And that is a quick overview and some examples on how to solve exponential equations when we can't use changing the base and we have to use a log.